Okay, so good day, everyone. So let's proceed to our next topic, which is a profile leveling. Okay, so profile leveling. So this is the process of determining differences in elevation along a fixed line at designated short measured intervals is preferred to as profile leveling. Okay, so that's the purpose to determine the differences in elevation. So it is executed to provide data from which a vertical section of the ground surface can be plotted. Okay, so later I will present this vertical section that is being mentioned here. This profile is necessary for the uh, design and construction of roads, railroads, canals, culverts, bridges, sewer lines, and etc. So the fieldwork involved is identical to differential leveling, since it is also requires the establishment of turning points or TP on which foresight and backside readings are taken before the terminal point is reached. Okay, so still in profile leveling, we also have this foresight and backside that I discussed last time. Okay, so the main difference between these two methods of leveling lies in the number of foresights taken from each setup of the instrument. So in differential leveling, only one foresight is necessary, whereas in profile leveling, any number, okay, so any number of foresights can be taken. So that would be imminent later now as we go along with the table and on how to perform profile leveling. So profile leveling, a series of benchmarks intended for use at a later date are also set up. Okay, so definition of terms. So to enable the student to better understand profile labeling work, so the following terms are defined. So first is profile. So the profile is a curved line which graphically portrays the intersection of a vertical plane with the horizontal or with the surface of the earth. So it predicts ground elevations of the selected critical points along a surveyed line and the horizontal distances between these points. Okay, so we'll draw that later. This curved line is being mentioned here. Stationing. So a numerical designation given in terms of horizontal distance. Okay, so again, when we talk about stationing, so we talk about horizontal distance. Okay, any point along profile line is marked away from the starting point. So each stake used is marked with its station and the plus. Okay, so later we will uh, discuss more about the stationing and the plus. Third one is the intermediate foresights. Okay, so intermediate foresights, so these sites, which are also known as the ground rod readings, are taken along the center line of the proposed project to provide an accurate representation of the ground surface. So intermediate foresights are observed at regular intervals and at points where sudden changes in elevation occur. Okay, so later we will know more about intermediate foresights. Fourth one is the full stations. So these are points which are established along the profile level route at uniformly measured distances. Okay, so these points are usually made in multiples of 150, 30, 20, or 10 meters. It uh, depends on your decision on what would be your full station. Okay, so this is uniform. Okay, for this is the keyword there at uniform measured distance. Okay, so uniform they measure distance. Next is the plus stations. So any other intermediate point established along a profile level route which is not designated as full station is called a plus station. So these points are taken at breaks in the ground surface slope and at critical points such as the intended location of culverts, bridges, and other structures. Okay, so there would be some points along the project that uh, there's a need to really get the elevation there. So there are possibilities that we'll be using plus station no, at these particular points. Okay, if you wanted to know the elevation for culverts, for bridges, and other structures. Six is vertical exaggeration. It is a process of drawing the vertical scale for a profile much larger than the horizontal scale in order to accentuate the differences in elevation. Okay, so there's a need to at least exaggerate the profile later, specifically for vertical distances to really emphasize the differences of elevation. Then lastly is for profile paper. So a special heavy grade wrapping paper used for plotting profiles. So the paper has horizontal and vertical lines drawn in green, blue, or orange, which are spaced accordingly to represent certain distances to the horizontal and vertical scales. Okay, so let's proceed to the procedure of profile leveling. Okay, so before profile levels are run, so the line joining the initial and terminal points must first be established. Okay, so meaning you must have an initial point or your starting point, then your terminal point or your end point. Okay, for you to know the possible route of your profile. Okay, so a transit and tape survey is undertaken starting at the beginning of the line, which is designated as station 0 plus 00. So this would be your starting station. So the length of the level route is measured and stakes are set at each full station to define the path to be followed. Okay, so you have to decide what would be your full station, the specified distance here. Okay, depends on your decision 150, 30, 20, or 10 meters. So next is the instrument is set up at a convenient location and backside is taken on a reference benchmark near the initial point to determine the height of the instrument. Okay, so this would be your first procedure to know the initial and terminal points, then decide for your full station, then this is will be your second procedure. Okay, so set up your instrument, then at least take a backside on your benchmark, then determine the height of the instrument. So it is preferable to set up the level about 20 meters, okay? 20 meters away from the level route when readings must be taken on a series of intermediate points. A suitable setup should be selected such that the rod is visible through the telescope and rod readings could be made more easily. So a series of intermediate foresights are next taken along the center line to determine elevations of ground points. So this is done without transferring the instrument. Okay, so later we will visualize all of this procedure. By the time it is no longer possible to continue with the foresight readings on intermediate points from the instrument position, so a turning point is established. So that is the purpose of a turning point. Now this permits the instrument to be moved to a new location which will allow additional foresights to be taken forward of the line or just to continue the line of levels. So intermediate foresight reading should be taken at regular intervals of 10 to 30 meters along the center line. And at points where there are abrupt changes in elevation. So the points foresighted should provide data which will portray accurately the configuration of the terrain along the level route. So preferably guys, the regular interval. So there's a range 10 to 30 meters, but the preferable interval would be 20 meters for your full station. Then, uh, then there are circumstances that you will not be using the 20-meter interval. No, that is due to the abrupt changes of elevation. So there might be possibilities that your interval is less than or equal to 20 meters if you decided to have the full station of 20 meters. Okay? Then benchmarks may be established ahead during the execution of a transit and tape survey, or at the same time, profile leveling is undertaken. So usually benchmarks are spaced much farther apart when the difference in elevation along the level route are not so large. So the spacing should be made closer where the differences in elevation is quite considerable. Okay, so that is the condition there. Okay, so the spacing of your readings should be much closer when there is a abrupt change in elevation, or there's a need to consider uh, the changes or the differences in elevation. So it is important that benchmarks be so located that they will be not disturbed or obliterated during any construction that may be undertaken later. So also, since benchmarks are indicated to be used as reference points for determining differences in elevation. So it is important that their elevations are accurately determined and subsequently verified as well. Okay, so uh, there's a example here for profile leveling. So figure 19-3 shows a schematic arrangement of a profile level route from benchmark 33 to benchmark 34. So expect that your BM33 is your initial point and your BM34 would be the terminal point. Okay, so the values indicated represent foresight, backside, and intermediate foresight readings taken on station along the route. So we are tasked to prepare and complete the profile level notes for the portrait information. So also show the customary arithmetic check, and we're tasked to plot the profile of the given schematic arrangement. Okay, so from our first procedure, so we already established the initial and the terminal points. Okay, then next is a transit in tape is undertaken starting at the beginning of 00. Okay, so for this example, so he or she decided to have a full station of 100. Okay, so full station of 100. So 1 plus, okay, the meaning of 1 plus 00 is this is 100, 100, 100 meters. Okay, so say if this station is 1 plus 30, so the reading for this distance is 130 meters. Okay, so say for example, so for 2 plus 00, so this is 200 meters. Okay, so for this example. Okay, then the instrument is set up at a convenient location, and a backside is taken on the reference benchmark near the initial point to determine the height of the instrument. Okay, so I think uh, so correction. So this is your BM33, and 0 plus 0 will be your initial point for your terrain. Okay. So the instrument man decided to set up his instrument here. Okay, so for him this is the most convenient location in order to at least sight the points along the route as many as he can. Okay, so this is the convenient first location. Then after that, the instrument man will try to have a backside here for your BM33. So for your benchmark, so the first type of sight in profile leveling is a backside, no? Or this is backside, so 2.33. So backside, in order for you to determine the height of the instrument for the first setup. Okay, so and also guys, for your benchmark, the elevation should be known at that point. Okay, so if you plot or if you tabulate the points, so you have the stationing, the backside, the height of the instrument, the foresight, and the what we call the intermediate foresight and the elevation. Okay, so for BM33, this is a known elevation which is 328.7. Then as you set up, then you will sight the BM33, and that would be your backside. So your backside there's 2.33. Then elevation, okay, so elevation plus backside would be equal to 331.02 meter, and that would be your height of the instrument for your first setup. Okay, so this is for the first setup. So this is HI1, okay, first setup. Then after that, you'll try to have a intermediate foresight as many as you can along the center line of your route. Okay, so this would be your intermediate foresight for 0 plus 0, then intermediate foresight for 1 plus 0, then intermediate foresight for 2 plus 0, then intermediate foresight for 3 plus 0. Okay, so record all of those stations, then also record the intermediate foresights. Then after recording the intermediate foresight in the station, then you'll try to determine the elevation at that point, okay, or at that station. So how to get the elevation? So just simply uh, deduct the intermediate foresight. Okay, so that is the height of the instrument minus the intermediate foresight at that station. Okay, so you'll be getting the station or the elevation at station 0 plus 0. Then again, the same with station 1 plus 0, station 2 plus 0, and station 3 plus 0. Okay, so just simply deduct the intermediate foresight to the height of the instrument. Okay, so now the instrument man cannot anymore see the next station. Okay, so meaning your next station would probably be this 4 plus 400 meter station. Okay, so 4 plus 40 station. So it is too far for him to see the readings in your rad. So he has to establish the turning point as mentioned here. Okay. So this is done without transferring. Okay, take note, transferring the instrument. Okay. Okay, so ito. So by the time it is no longer possible to continue with the foresight readings on the intermediate points from the instrument position, so it goes that a turning point is established. Okay, so once the reading is not readable anymore. Okay, so you must have a turning point. No, any point that is near the route. Okay, so going back to the definition. So I think we don't have definition here for turning point. Okay, but turning point, it is a new location which will allow additional foresight. Okay, so any point, guys, along the route. Okay, so as you establish the turning point, then the reading for your turning point is not IFS, no. The reading in that point is FS. Okay, so for foresight. Okay, so as you read the foresight the same way the other station, then you have to deduct the foresight to the height of the instrument for you to get the elevation at TP1. Okay, so therefore the elevation at TP1 is 127.59. Okay, then after getting the foresight for your TP, then that's a time that you need to transfer again at any convenient location wherein you can site you can get as many as intermediate foresights. Okay, so after this FS for your TP1, then transfer instrument here. So you will have the instrument height of the instrument 2. Okay, so this would be your height of the instrument 2. Okay, so in order to get this height of the instrument at point 2, then just uh, simply follow the elevation at TP1, then plus this is the back side. Okay, from HI2, then you need to have a backside to your TP. Then record that backside. Then backside plus height of the instrument would be equal to the height of the instrument, HI2. Okay. So after getting the backside for your TP1, then you need to start again getting the intermediate foresights to your desired station, no, at center line for your project. Okay, so you have 4 plus 40 here, then 2.2 the intermediate foresight, 5 plus 00, so intermediate foresight, 3.7, then 6 plus 00, 1.6 intermediate foresight. Then again uh, the instrument man cannot anymore read the the rod reading here at station 8 plus 00. So you need to establish again a turning point. So you have TP2 here. Okay, so you have TP2. So for your TP2, again, do not forget to get the foresight reading from HI2 to your TP2. Okay, so you will have this TP2 here. Then height of the instrument 2 minus, okay, so height of the instrument 2 minus the foresight, then you will have the elevation at TP2, which is 327.3. Okay, so again, after getting the foresight for your TP2, then transfer your instrument again to the most convenient location for you to sight the uh, IFS of your center line. Then after setting up the HI3, then again you have to sight TP2 for you to get the backside. Okay, so after getting the backside, then since you have the elevation for TP2, Then elevation for TP2 plus the backside. Then you will have your height of the instrument 3. Okay, so this is the equation there. Okay, so 327.3 plus the backside 2.22. So HI3 is 239.52 meters. Then after getting the backside, then going back again to the procedure. So proceeding with the IFS reading for each station, 8 plus 00, 9 plus 00, then 10 plus 00, then 11 plus 00, and lastly for your BM 34. Okay, so for your BM34, again, the last site would be your 4 site, so 2.45. Okay, so the elevation for BM33 would be 327.07. Okay, so that would be our goal. We must get the elevation for our terminal point, which is BM33. Okay, so that is how to at least analyze or tabulate the solution. So, okay, so to reflect the route, so say this is the route. This is the route that you are trying to survey. Okay, so this is the route you're trying to survey, guys. Okay, so all these points are the points along the center line. Okay, that is the point along the center line. Okay, so our task now, after tabulating all of the elevations, the backsides, the foresight, the IFS, and the height of the instrument, then our next task is to plot the elevation and the stationing. But before plotting, we must at least have a arithmetic check. Okay, so for the arithmetic check, so you have to at least have the elevation of BM33, then plus the submission of backside, which is equal to 7.31. Okay, so just simply add all of these entries here for your backside. Therefore, you have submission of backside, which is 7.33. And the same with foresight. So you have these entries here for your foresight. Then just simply add arithmetically all of these numerical figures there. Okay, so your submission of foresight would be equal to negative 8.94. So again, this is positive value for backside because backside is also considered as the plus side. In the plus side, as discussed last time, and your foresight is considered as the minus side. Okay. So to have the arithmetic check or to validate your tabulation, then you have this arithmetic check elevation of BM33 then plus the backside. So you will be getting the sum which is equal to 336.01. Then deduct the summation of foresight. So the result here uh, should be equal to the elevation of BM34. So this is 327.07. Then you have to check, okay, if the elevation here for BM34 coincides with your arithmetic checking. Okay, so now this is the important part in doing the profile leveling to plot the profile. Okay, in here you must have the date of the time you perform, then the location or the name of the party, then the chief of the party, or you may write your name here. Then the profile level route from BM33 to BM34. Then the location of your surveyed route. Okay, so scaling here is very important. Okay, so you must have a horizontal scaling, meaning this is for your station. Okay, so you have 1:100 or 1 cm. 1 cm is equal to 100 meters in actual. Okay, 1 cm the dimension or measurement here would be equal to 100 meters in actual. Okay, this is for stationing, guys. For horizontal, this is for your stationing. Or this one below. Then you must also have a vertical scaling for your elevations. Okay, for your elevations. So 1 cm for your vertical scaling is equivalent to 5 meters for actual measurement. Okay, so say for example, say for example for station 00. Okay, so this one, station 00, the elevation at station 00 is 329.3. So you have to plot 329.3. Okay, so this is 320, 325. So I think this one is 329.3. This is 329.3. Okay. Okay, this is for station 00. So how about for station 101? Okay, so station 101, so the elevation there is 3.28.8. So you have to plot. Okay, so 1 plus 00. So I think this point here is 328.8 meters. Okay, the same with 2 plus 00. 2 plus 00 is 329.8. 329.8. So I think for this one. And with the rest of your stationing, you just simply plot all of those, guys. No? All of those points necessary in your profile until you reach BM34. Okay, so BM34 is 327.07. So if you will try to manipulate it here, then this point here for BM34 is 327.07, this point. Okay, so for 11, say for 11 plus 00, elevation there is 328.4. So this point is 328.4 meter. Okay. So if you wanted to include the TP, then you may also include this one. So I think for our example, TP, okay, so the TP here is included in your route. Okay, the same with, I think the same with TP2. Since the TPs, the TP1 and TP2 is included in the plotting of the profile. Okay, so this is the purpose of having a plot or doing the profile labeling for us to at least know the curve, no? The elevation at the desired position, specifically at our center line of the route. Okay, this is very useful in constructing roads. Okay, so we need to have this particular graph. Okay, so thank you guys for listening. So instructions for your assessment task will be posted in your UV. Thank you guys and keep safe everyone.